All right, now, first of all, I need you to notice something. And that is, we have variables in the denominator. And whenever that happens, you have to be very, very careful. Now, if I factor this guy, as it turns out, we get the same guys we had in the two previous fractions, right? So over to the side, remind yourself, x cannot be who? X can be 0. That's fine. So, but you had the right idea. The idea was the denominator can't be 0. You were right. You just said it wrong. So then x itself can't be -5 or 3. Good. So if during this process I end up with x being -5 or 3, I have to throw it away. I can't keep it. All right? Variable in the denominator, warning. Step 2. We have a fractional equation, but kind of don't like fractions, right? So we can clear the fractions by multiplying both sides by the common denominator. Because in algebra, we're always allowed to do the same thing to both sides, right? So when I distribute here, do you see that the x plus 5s are going to be gone? And I have left 1 times x minus 3 equals, multiply here, the x minus 3 is gone, and what's left? And also what? You're right, the 2. That's right. And I multiply here, and everybody's gone except the 2x plus 2. So step 1, clear the fractions multiplying through by the common denominator, right? And then we solve this. And so let's see, this is 4x. Subtract x from both sides, that's 3x. That's 12. Subtract 12 from both sides, that's -15. And supposedly, x is -5. But we said at the very beginning, because we were being careful, right? X is not allowed to be -5. I have nothing left. Meaning, nothing works. You cannot find a number to plug in for all the x values to make the left-hand side equal the right-hand side. If you can find a number that works, you get an A for the class, never show up again. 5, same thing. We have a fractional equation. The common denominator is what? A, B, C, and X, right? And a quick review, how do you get a common denominator? Well, you play the game of communism. The game of communism is everybody gets the same thing. And so the AX goes, that's not fair. That guy has a B, the other guy has a C. Okay, good, now I feel better. BX goes, that's not fair. The top guy's got an A, the bottom's got a C. Now I feel better. The bottom guy says, oh, I want the A, I want the B, and I want the X. And now they're all A, B, C, X. That's all you do to get a common denominator. You even everybody out so that they all have the same thing. Okay? All right, so if I multiply here, who's gone? AX, who's left? Multiply here, who's gone? Who's left? Multiply here. Who's gone? Who's left? Now, who is the star variable? X. Solve for X. So then I'm going to be weird. I'm going to move the ABX to the left to make it positive. And I'm going to move the BC to the right. How do I get X by itself? Divide by AB. And you are basically done. You can stop, you're done, you're done, you're done. Now, there are people, not you, I know, who, oh, cancel the A, cancel the B, this is so much fun. Canceling is the worst, right? Now, if you want, you could do this. Because the AB on the bottom is what? A common, right? Same denominator for both. You could do that. And then you can reduce to this if you want to. But I'm not saying it's any better. Okay? But here's the thing. If you ever take a multiple choice test, right? And you get this answer without the stupid canceling. And that answer isn't listed. That's the bad part of multiple choice, right? Somebody else thought of another way to write your answer. And instead, this one is someplace. Then you have to understand this idea of a common denominator, don't you? Okay. And then the A students say what? Since they're variables, and since I don't want the denominator to be 0, we need to say, by the way, don't forget, A and B better not be 0. Okay? A students, think of the little things. And I want you to be A students, and so I'm going to remind you of that over and over and over again to get you ready. All right?